Hey problem solvers, in this video we're going to be doing some 3D geometry questions. To help me out, I have some 3D shapes I've made out of Play-Doh and a calculator, a scientific calculator. This is a regular scientific calculator with a writing area that comes with it that you can write on with a pen. So this is nice because if you're revising and you come across some formulas you want to remember, you can jot them down, and when you get to class you can open up your calculator and they'll still be there. So once, while you're trying to remember them, it's good to have them available and you can write them down as you go. So if you're trying to remember the trigonometric ratios, you can jot them down and they'll be available for you. This calculator was sent to me by NEWYES. If you want to get one for yourself, there'll be a link in the description. It'll be just a regular price of a scientific calculator, but you get this nice bonus writing area with it. Okay, so onto the questions. I have two more basic questions and two high-level questions I'll be going through. Starting off with this one here. It says the diagram shows a triangular prism. Work out the total surface area of the prism. Now, a lot of people have trouble interpreting two-dimensional diagrams of 3D objects. That's why it's helpful to have the object. If you're learning this topic maybe for the first time, or if you're teaching this topic, it can be really helpful to have some shapes available. Maybe you've got some made out of wood or something. You don't have to use Play-Doh, but Play-Doh will do if that's all you have. So to work out the surface area, we're going to have to work out the area of each face of this shape. They give us the dimensions. They tell us that this slanted edge is 13 centimeters, this long edge is 20 centimeters, and this edge here is 5 centimeters, and this other edge is 12 centimeters. So to work out the surface area, we're going to have to work out the area of this face, the face on the back here, and the two triangles on the ends. They'll have the same area, so if we just work out the area of one, multiply that by 2, that will do. Okay, so the mistake people make with these types of questions is they get the dimensions wrong. They mix up this 5 centimeters here and they don't realize that it's also the edge of the back edge. So if you're looking at it like the diagram is drawn, they mix up the 5 centimeters on the ends here, or they just make small errors with the dimensions. So we're going to try to not make any small mistakes here. So the large face has dimensions 13 centimeters and 20 centimeters, so that area is going to be 13 times 20. 13 times 2 is 26, so that's going to be 260 centimeters squared. Then we want the bottom edge, that's the face on the ground in the diagram. The dimensions of that are 20 and 5 centimeters, so that's going to be 20 times 5. 2 times 5 is 10, so 20 times 5 is 100 centimeters squared. Then we want the back face. Its dimensions, be careful, is 12 and 20. Even though the 20 is not written over here, it's still going to have the same length, right? So that area is going to be 12 times 20. 12 times 2 is 24, so that's going to be 240 centimeters squared. And then we need the triangles. Remember, the area of the triangle is half base times height. The base is 5 centimeters, the height is 12 centimeters. So we're going to do 5 times 12 divided by 2. That's 60 divided by 2, that's 30 centimeters squared. And remember, we had two of those triangles, one on either end of the prism. So we multiply that by 2. And if you wanted to take a shortcut, you could just not divide by 2 here and you'd have that area, but let's do 30 times 2 and we get 60 centimeters squared for the two triangles on the ends. And that should be all of the areas we need to consider. Now we just need to add those up. So we've got 260 plus 100 plus 240 plus 60. If we add those up, we're going to get 16, carry the 1, 2 plus 1 plus 2 plus 1 is 6. So we get 660 centimeters squared for the total surface area for that shape. Okay, on to the next question. This question says a cube is placed on top of a cuboid, as shown in the diagram, to form a solid. The cube has edges of length 4 centimeters. The cuboid has dimensions 7 centimeters by 6 centimeters by 5 centimeters. Work out the total surface area of the solid. Okay, so if we're looking at this shape, to work out the surface area, I would start by working out the edges that are not, on top here. This bit's going to be a little bit more difficult, but just start off by working out the surface area of the other sides, and then we'll work out this bit here. Okay, so the surface area of those uncovered sides. This side's going to be 7 by 5, and we're going to have 2 of those, right? One on the front, one on the back, and we'll have 2 of the other 2 sides as well. So we're going to have 7 times 5 times 2. That's going to be 70 centimeters squared. Then the other 2 sides, 5 times 6 times 2. So 5 times 6 times 2, that's 30 times 2. That's 60 centimeters squared. Then the bottom of the cuboid is going to be 6 times 7. So 6 times 7 equals 42 centimeters squared. And we're not going to multiply that by 2 because the top face, we're covering that up slightly with the cube. So we'll leave that for later. So we have all of the faces of the cuboid, the uncovered faces. Then the cube, we know it has a side length of 4. So its faces are going to be 4 times 4, and we have 5 of those, 5 uncovered faces of the cube. So we're going to do 4 squared times 5. That's 16 times 5, or 4 times 5 times 4. 20 times 4, maybe that's easier to think about. That's 80 centimeters squared. And so now let's deal with this edge around here. Well, we know this face, we've already worked that out, was 42. That was that one there, 6 times 7. And we just need to work out the area covered up by the cube, which would be 4 squared, which is the area of the side of the cube. So to work out this edge around here, it's going to be 42 take 16. 42 take 16, that's 26 centimeters squared. That would be that edge around there. And that should give us the total surface area, so we just need to add these up. What's the easiest way to do this? Well, let's just go down. So 2 plus 6 is 8, and then 7 plus 6 is 13, 17, 25, 27, 278. So final answer there, 278 centimeters squared. And I'm just realizing the camera's shaking a little bit. Sorry if that's a little bit annoying. On to the next one. Okay, this question is a bit more challenging, and we will need our calculator this time. It says a solid cone is joined to a solid hemisphere to make the solid T shown below. The diameter of the base of the cone is 7 centimeters. The diameter of the hemisphere is 7 centimeters. The total volume of T is 120 pi centimeters cubed. The total height of T is y centimeters. Part A says calculate the value of y. Give your answer correct to 3 significant figures. Okay, so where to start here? Well, we have the radius of the hemisphere, and that's all we actually need to work out the volume of the hemisphere. So we can start by working out the volume of the hemisphere, and that should allow us to then find the volume of the cone and then work out y. So starting off with the volume of the hemisphere, let's call that VH. That's going to be, now would it be 4 and 3 pi r cubed? If that's the volume of a sphere, we want half of that. So if we multiply this by half, 4 on 3 pi r cubed multiplied by a half, that's going to be 2 on 3. So we can just say the volume of a hemisphere is 2 on 3 pi r cubed. So we can say 2 on 3 pi, and the radius is half the diameter, So half of 7 is 3.5 cubed. That's going to give us the volume of the hemisphere. And we know the total volume is 120 pi centimeters cubed. So then we can say the volume of the cone, let's say VC, would be 120 pi subtract the volume of the hemisphere. So 120 pi subtract 213 pi times 3.5 cubed. Okay, and we're going to be able to work backwards from this answer to get h, the height of the cone, and then y, the height of the solid. So this, because it's the volume of the cone, should also equal 1/3 pi r squared h. Okay, so let's work out this using our calculators. So we've got 120, the pi button is above the comma here, so second function comma, and then subtract, put some brackets, 2 on 3 pi again, multiplied by 3.5 cubed. The cubed, you can use the y to the x button, so 3, and then another set of brackets. That should give us our answer. So we get, for this, 287.19 and so on. Now that's the volume of the cone. And remember, we want h. So we want to do some algebraic arranging here to get h. So h is going to equal this number we just got, so 287.19 multiplied by 3, because the third is on this side. So if we want to get h by itself, we need to multiply by 3 and divide by pi r squared, right? Pi r squared, and that's going to give us our h. So we want to multiply this number by 3 and then divide by pi r squared. So multiply by 3, divide by pi, and r was 3.5 squared. Okay, so that's our h, 22.38. So 22.3877, and it goes on. And we're only needing this to 3 significant figures, so we're going to end up rounding this off. Now we have h, which is the height of the cone, and we want y. So what's the last operation we need to do here? Well, what would this length be? That would be the radius of the hemisphere. So we know that's 3.5. And we know h now is 22.39 approximately. So to work out y, we just need to add those together, right? So y is going to be 3.5 plus our answer here. So just add on 3.5, and we get 25.8877, and we need it to 3 significant figures. So rounding that off, the number after the decimal place is the 3rd significant figure, so it's going to be 25.9. So final answer, 25.9 centimeters. Okay, the second part of this question says, the diameter of the base of the cone and the diameter of the hemisphere are both increased by the same amount. Assuming the total volume of T does not change, explain the effect this would have on your answer to part A. Okay, so in this solid, that's getting stretched out, right? So I haven't actually made this shape out of Play-Doh, but you can imagine if I have this shape here, and let's say this width increases, in other words, I squash it, so that width is now increased, right? What's happened to the height? The solid state, the amount of volume has stayed the same. This width has increased, the height has decreased. So that would be your answer here. Explain the effect that would have on your answer to part A. Y would decrease, or the height of the solid would decrease. Okay, all right, on to the next question. Okay, last question for this video. This question says VABCD is a solid pyramid. ABCD is a square of side 20 centimeters. The angle between any sloping edge and the plane ABCD is 55 degrees. Calculate the surface area of the pyramid. Give your answer correct to 2 significant figures. Okay, we're going to need some trigonometry for this question, so it's a bit more difficult than the others. And be careful when it says the angle between any sloping edge and the plane is 55 degrees. So that means these edges here, not the faces, but the actual sloping edge. For some of you that might sound obvious, but I could see people saying, oh, just the angle between the face and the bottom is 55, but it's only the edge here. That's the only angle we're told. So to work out what do we actually need to work out? Sorry, the surface area of the pyramid. We're going to need to work out the area of these faces, the triangular faces. To do that, we're going to need the height here, from the tip to the middle of the base. We have the base length. They tell us that's 20 centimeters. But we need to work out both the length of the slanting edge and the length from the tip to the middle of the base here. So to do that, the first thing we can do is, well, we can work out the length from the corner to the middle of the pyramid. So the middle of the base, from this corner to the middle, we can work out using Pythagoras. Because if we're told the base is 20 centimeters, from the middle of that base, if we split it in half, that will be 10. And then if we go to the middle there, the middle of the square, that length is also going to be 10. So we can work out that diagonal length. So basically what we've done here is drawn a triangle from the middle of the base. Oh, I'm messing my pen up. We've drawn a right triangle like that. This length is 10. They tell us that in the question. This length is 10, so we can work out this hypotenuse. Okay. So let's call this point x. So we can say ax squared is 10 squared plus 10 squared. So that's 200. Okay. Then we're going to work out the length. Well, we can either work out the length of the sloping edge or the length Vx. That's the height of the pyramid. So now we're working out the height from the tip to the middle of the base. Because we know this angle is 55 degrees, and this is where our trigonometry comes in, we can draw this right triangle separately. So what we actually have here is a right triangle with an angle of 55 degrees, and this length we know is the square root of 200. That's what AX would be by itself, square root of 200. So I'm going to do a bit of dissection here just to make this really clear. What we've done is we've cut our shape in half, right? And we're looking for, we've got this triangle here, right? That's a right triangle. We know this angle in here is 55, and we're looking for these two lengths. And we're going to do that using trigonometry. Okay. All right, so you should know, or hopefully you know, how to find the length of a triangle if you're given an angle and a side. Well, there's a bit of a clue on our calculator here. Sine of theta equals opposite over hypotenuse. We can't actually use that ratio yet. We have to use a different ratio. So which length it depends which length you want to find. If you want to find the sloping edge, the hypotenuse of this triangle, you can use the cosine ratio. Remember, cosine of theta equals the opposite side, the adjacent side over the hypotenuse. I need to write that down on my calculator so I remember. And we have the angle, we have the adjacent side, we're going to be able to work out h, the hypotenuse. So we can say cosine of 55 equals the square root of 200 over the hypotenuse, which is the length we're looking for. Now on our diagram that's labeled AV, so let's write AV. So then AV is equal to, if we rearrange this, multiply by AV, divide by cosine of 55, that's going to be the square root of 200 over cosine of 55. So let's work that out. Square root of 200 divided by cosine of 55. Now hopefully I didn't need brackets there. So we get 24.65 approximately. I'll just double check. Yep. Okay, 24.65. And that goes on. So we have that length, 24.6 approximately. That's the sloping edge. And we can use that now to work out the length from V to the middle of the base. So if we look at our triangle again that I've demolished, we've got the length of the sloping edge. We know the length to the middle of the base. And now we can use Pythagoras to work out the height of that triangle, right? From the tip to the middle of the base. So we can say then, let's call that V, let's call that point M. So that's VM. VM would equal the square root of AV squared take AM, which was 10 squared. Okay. So to do this calculation, we're going to store this answer in our answer function. So, and then we can do second function square root of answer squared, and we need some brackets here, subtract 100, and that should do that calculation for us there. So that gives us 22.537. So 22.537 and so on. So that was VM, this length. No, sorry, not that length. The length from the middle of the base of the pyramid to the tip. And now to work out the surface area, we have the height of the triangle on this face of the pyramid and the base. All we need to do is use our area of a triangle formula, multiply the height times the base, and do that 8 times, right? So we've got 1, 2, 3, 4, 5, 6, 7, 8 lots of those triangles. If you understand my meaning there. So 8 lots of these triangles here. Okay, so let's work out the area of one of those triangles. So it's going to be half times the base was 10 times the height. That was this number we worked out, 22.537. So we're multiplying that by 5 essentially, multiplied by 5. 112.68, and we had 8 of those, so multiplied by 8. And then we also have so 112.68 times 8 is 901.48, and we also have the base. So don't forget the square base that has an area of 20 squared, so 400. 20 squared equals 400. And then our total surface area, is going to be those two added together. Right, so add on 400, and we get 1301.48 and so on, and we need to round that off to 2 significant figures. So to 2 significant figures, these are our first 2 significant figures. The next one's 0, so that's going to be rounded off to 1300 centimeters squared. Okay, so they were 4 3D geometry questions, a bit of a mixed bag of topics there. I just wanted a general kind of mix of questions, so hope you found that useful. Please leave a like if you did, subscribe if you want to see more content, and I'll see you in the next one. Bye for now. Also, if you want this calculator with this writing area, check out the link in the description. I think that would be really useful for, you know, keeping note of any formulas that you need to be using in class. Okay, thanks for watching. Bye.